This is the tutorial for Chapter 9, Section 4, Factoring and Solving Quadratic Equations, day number 2. So what we've got here is we've got a quadratic equation, but it's not quite in standard form. So what standard form is when we get all the terms onto one side, we set it equal to 0. And so that's what I'm doing here. I'm subtracting the 3x squared from all sides, adding the 4x so that I get everything onto one side. So when I do that, this leaves me with 18x squared plus 9x minus 35. So always look for common factors. See if there's something that's common between, and I don't see anything, so we've got a tough factoring problem. So first thing I'm going to do is draw two sets of parentheses. I look at that last digit sign, and that tells me that I have to subtract the outside and inside terms. And when I do so, I should get 9x. So that tells me I probably need to break down the 35 to 5 and 7, and that's where I'm going to start. It has less factors than 18. 18 has a few extra ones, and so my choices for 18 are 1 and 18, which I don't think it will be, 2 and 9, or 6 and 3. And I'm kind of going with 6 and 3 initially. I think I might be able to make that work. And so when I look at this, I've got 6 times 5 gives me 30. And then if I do 3 times by 7, that gives me 21. You see the 30x, the 21x, those will subtract to make 9x. And so to make it a positive 9, I want 30 to be positive, and I want 21 to be negative. So now I know I have the factoring done right, so I can go ahead and use the zero product property and set the two factors equal to 0. And so when I do that, I've just got some opposite operations. Move the 5 over, so that changes it to its opposite sign, and then divide by 3, and so I end up getting negative 5/3 as one of the values. Over here I have to add the 7 to both sides, and then divide by 6, and I end up getting 7/6. So negative 5/3 and 7/6, the two x-intercepts. So let's take a look at the next one. Here I have to add the 3n squared to both sides. I'm going to subtract a 9n, and I'm going to subtract an 11 from both sides. So just doing the opposite operations of what I have on the right-hand side, and I'm left with a 6n squared minus 11n, and then minus 10 equals 0. So another tough one because I have a negative sign again, so outside and inside terms are subtracting to make 11. So my guess is that I probably need to break down the 10 to 5 and 2. The reason is 11's not too big, and I don't think I'm going to multiply 10 by a number. I think it'd make it too big. So looking at these numbers, I don't think I'm going to multiply by 6, because the only way 6 would work is if I multiplied 6 by 2, and that's going to end up giving me 7n when I go ahead and subtract the 5 from the 12. So I don't think it's this. I think it's going to be 2 and 3. I just need to figure out the order. So my guess is I'm going to put the 3n here and the 2n here. I think that'll work because this makes 15n, and this makes 10 or 4n, and when I do subtract those, I do get 11n. To make it a negative, I'm going to make 15 negative, 4 positive. So put the minus sign here, the plus sign right there, and I'm ready to go. So I'm ready to use the zero product property. 2n minus 5 equals 0, and I also have 3n plus 2 equals 0. So when I add the 5, that gives me 2n equals 5, and subtract the 2, 3n equals negative 2. So divide by 2, n is going to equal 5 halves, and here I divide by 3, n is going to be negative 2/3. So negative 2/3, comma 5 halves, and that's going to be our two solutions. So moving on to the next problem, we've got some geometry problems here. So these could either be a volume problem, or more typical on this type of problem is an area problem. And so it's a pretty basic one. It's just dealing with either a rectangle or a triangle. We'll see both of them here. So it says the rectangle deck patio, or a landscaper is designing a rectangular brick patio. She has enough bricks to cover 144 square feet. So this is our area right here. And it says she wants the length, we'll call this the length, of the patio to be 10 feet longer, 10 feet greater than the width. So we'll say that the length is 10 more than the width. And this is my width right here. And so what are the dimensions? Well, I know the area formula for a rectangle is length times width. So we're just substituting our numbers in there. 144 equals the W plus 10 multiplied by W. So I distribute, and I've got this. 144 equals W squared plus 10W. Well, I got to put it in standard form, so I got to move the 144 over and then figure out the factors that make 144. So a lot of people know 12 times 12, but that's not going to subtract to make 10, so we need to pull those numbers apart a bit. And so when I do that, I'm going to end up trying, and what you can do about this is you can break these numbers down to like 4 and 3, and you see how this makes 4 and 3. Those 12 times 12 makes that number. And so I can reorder some of these values. Maybe take like the break the 4 down a little bit further, 4 and 2, 2 and 2, and let's break that down just a little bit, 2 and 2, and I got the 3, and then here I have 2 more 2's, and then another 3. So let's pull some of these 2's together. I'm going to take 3 of them, and I end up with 8, and then I'll take the other numbers, the 3, and the 2, and that makes 9 times 2 makes 18. So 18 times 8 also makes 144, and those numbers will end up working. So they'll subtract to make 10. So W and then 18 and W and 8. And so to make a negative 10, I'm going to make the 18 negative and the 8 positive. And that's going to end up working out. See, W minus 18 equals 0, and a W plus 8 equals 0. So I'll subtract the W, or subtract the 8 from both sides. So W could equal negative 8, or W can equal 18. Well, that's fine if it was just a regular problem, but this is not. This is a geometry problem. This is a problem that actually has some true meaning. So we aren't going to use the negative numbers. We're just going to use the positive numbers. And so in this case, I would end up, so I see an error right here. It doesn't make sense because length has to be 10 longer. So I'm going to switch that. I see that this should have been a positive sign, so that's going to switch my signs here. And it's going to switch these signs as well. So this will be negative. So my 8 here, and I'm going to erase this one since I crossed it out a little too soon. My 8 right here is going to end up being positive, and this 18 is going to be negative. So again, I can't have a negative width, so my width is going to end up being 8 inches, or 8, let's see what the units were in here, feet. It's a patio, that's right. And so 8 feet, and the length is 10 more than 8. So the length equals 10 plus 8, which makes that 18. So oftentimes you'll see that when you get one of the dimensions, the other dimension is that one that it wasn't, like it's that negative value. And so in this case, it's asking for the dimension, so you just say 8 by 18 feet, 8 feet by 18 feet. So here we have a triangle, a right triangle. And so here's our right triangle. It says that the base of the right triangle is 4 greater than the height. So take the height and add 4, and that's going to be the base. So the height is just right here is the other dimension going the perpendicular way, and we'll set up the equation. So 96 equals, and then remember our formula goes 1/2 base times height. And so 1/2 times by h plus 4, that's the base, and times by the height. Well, I've got this 1/2. I could get rid of that by multiplying it by 2. That'll cancel that out, but I got to multiply the 96 by 2. It's going to give me a little bigger number now, so I've got 192 equals, and then I'll distribute now, and so I've got h squared plus 4h. Well, moving the 192 over leaves me with this, h squared plus 4h minus 192, and this all equals 0. So I've got a factor to find out what the height is. So h and h make h squared. Now numbers that are pretty close to 192, when I take a look at those numbers, it's a big number, but if you look at the sum of the digits, that sums to equal a 12. And 12 is a number that you can divide by 3. So I know 3 goes into it. Now I know 9 doesn't go into it, but 3 does. Well, it's also even. And I'm thinking that 12 goes into it. So I'm going to think of, I'm going to try dividing this by 12 to see what the other factor might be. And when I go ahead and do that, I end up with 16. So 16 times 19 makes 192, and that subtracts to make 4. So I'm going to put those numbers in there. and I need to subtract to make a positive 4, so I'll make the 16 positive, 12 negative. So that tells me that h, when I go ahead and solve for h, I'm going to get two answers, positive 12 and negative 16. Well, the height's going to be the one that's positive, and that makes sense because the base is longer. Well, the base is just 4 more than the height, so the base ends up being this other number. And so it's asking for the base, so the base is 16 feet, or centimeters in this case. Last one was feet. So 16 centimeters, and the height in this case is 12 centimeters. And again, I got the 16 because 12 plus 4 makes that 16. So let's take a look at the last two problems here. And on this one, we're dealing with projectile or vertical motion is what the book calls it. And so what it is, it's a formula that goes this way. The height, and so this is the height above some surface. So typically it's above ground or above the water. So it kind of depends on the situation. So it's the height, and then it goes 1/2 ax squared. Well, in our case, we're always going to have one of two numbers. It's either going to be negative 16 or it might end up being negative 5. But oftentimes, if they're dealing in feet, it's going to be negative 16. Meters, it's going to be negative 5. So this will be given to us. And then it goes plus the initial velocity, and that's where the I comes in, times x. And so this VI just stands for the initial velocity. And so it'll be given to us in the problem. And then we have plus c. Well, the c represents the initial height. So it's our initial height. And so we're going to go ahead and we're given the formula here in this problem. And on the problem you end up having in your homework, you'll have to substitute in. They're going to give you the 14 is the initial velocity and 2 is the initial height, and you'll have to substitute it into the formula to make this. So here it talks about a group of friends tries to keep a beanbag from touching the ground without using their hands. Once the beanbag's kicked, its height can be modeled by this equation, where h is the feet above the ground and t is time in seconds. So we want to find the time it takes to reach the ground. Okay, the ground represents 0 for the height, and that's the key here. So sometimes if it was like 2 feet above the ground, then you'd put 2 in place of h. It depends on the problem. Here they're talking about the ground, so that means that h equals 0. So we're going to go ahead and rewrite our formula, and then we're going to factor. So before we factor, though, look for common factors. Make the factoring easy. And so I see a negative 2 I could pull out. And when I go ahead and do that, I'm left with 8t squared. And it's going to switch the signs now. It's negative 7t minus 1. Well, I've got different numbers, but they're easier to factor because now I've got 1. And 1 is just going to be 1 times 1. And numbers that multiply to make 8, well, I'm going to try 8t and t because you see I need to get the outer terms and inner terms to subtract to make 7. To make it a negative 7, I'll make the 1 negative, the 8, or the 1 here positive. And when I go ahead and solve, I get two answers, negative 1/8, and I get t also could be positive 1. Well, I'm not going to go with this one. They have that one because... So the reason why we have two answers is because if we looked at the graph, it goes this way. See, we've got the y-axis represents height in feet, and the time axis represents is in seconds in this case. And so you see how it started 2 feet above the ground. And so the graph goes like this. It makes that general shape, the parabola, and then it comes back down, and right there is 1 second. Well, the reason why we have the negative 1/8 is because the parabola keeps on going. This is what is actually happening here, this portion that I showed, but there is another section here, and I'll go ahead and fill this in as a dark section, but then everything else that I dashed in is actually continuing on. It's part of the graph, it's part of the equation, but it just doesn't make sense in the problem. So the only part that really makes sense is this. Well, the negative 1/8 came in from right here. You see it's below the 2 feet, and it ends up being on the left side of the y-axis, so that's why it ends up being negative. So we're just going to go with the positive one. So it's going to take 1 second to hit the ground. And so this next one, same thing. Height of a diver above the water during a dive can be modeled by this equation. So it says 8 represents the initial velocity. It's like when the diver jumps up. 48 feet is the initial height prior to her jumping. And so it says where h is the height in feet above the water, and t is time in seconds. Find the time it takes to reach the water. So that means that h equals 0 again. And so we're just going to write down the equation, negative 16t squared plus 8t plus 48. Well, I'm really fortunate here because I've got a big number I can take out, negative 8. That's going to make the problem a whole lot easier. So it becomes 2t squared and then minus t and then minus 6. And so now I've got an easier problem because I've got a prime number, 2t. So I know it's 2t and t. Now to make a 6, I think I need to break down the 6 to 2 and 3, and this will work because this will make 4t, 3t. To make it a negative t, I'm going to make the 4 negative. The 3 needs to be positive. So when I go ahead and set it equal to 0, I'm going to get 2 answers. T is going to end up equaling negative 3 halves from this one here. But then on this side, I get positive 2. So again, it's dealing with time, so we're going to go with the positive answer. So 2 seconds is the time it takes for the diver to reach the water. Those are the types of problems you're going to see on tonight's homework. Good luck.